Let us now consider perpendicular lines. Let's start very qualitatively here and consider the following two lines that we've been looking at all along. So the first line was y equals 2x minus 3. And the second line is y equals negative 2/3 x plus 4. What's important if we're going to try to construct perpendicular lines is the slope. It doesn't matter where the line is. If it crosses the original line at a 90-degree angle, it's perpendicular. But if it had crossed that line here, it would also be perpendicular. So the y-intercept value is not really going to be important. What really matters is the slope. Now, if I draw a perpendicular line somewhere across the line on the right, it would look something like that at a 90-degree angle. Now let's qualitatively analyze these quickly. First of all, if I look at the graph on the left, the original line slopes up. We'll say upward. So if you look at the perpendicular lines to it, they slope downward. This second line slopes downward. The line that is perpendicular to it slopes upward. So if you have a line with a positive slope, so this one had a positive, the original line, let me do this in blue, has a positive slope. The perpendicular line better have a negative slope. And in the second case, we have a negative slope value. And so the perpendicular line better have a positive slope value. Now we can go even further. In the first case, the one on the left, it slopes upward fairly steeply. It's in a 2-to-1 ratio. Every time you go over 1 unit, you have to go up 2. And the second line, if it goes up, or it goes downward, but it's not nearly as steep. Every time you go over 3, you go down 2. So not as steep. We'll just say less steep. If that were a hill and you were riding your bike, it would still seem pretty steep. But it is less steep. Okay. So, in fact, the slope is a fraction that is below 1. So in terms of lines, we could say it's not a steep line, whereas the slope of the first one is a 2-to-1 ratio. That's a number that's bigger than 1. So it's steeper than a 1-to-1 ratio. But now let's look at the perpendicular lines. In the left graph, the lines that are perpendicular slope downward, and they are not so steep. On the graph on the left, they slope upward steeply. So if the original line was less steep, the perpendicular line should be steeper. And if the original line was steep, then we get a perpendicular line that's not as steep. The classic example of this would be the axes themselves. Though the x-axis has no slope, the y-axis has an infinite slope. So the y-axis is as steep as it could be, while the x-axis has no steepness at all. So let's continue onward. Let me clear out the ink that we have. We know that for the first one, in order to get a perpendicular line, it has to go down not so steeply. But let's study the original line. It had gone over 1 and up 2. So it had gone over 1 and up 2. We now know that to get the perpendicular line, we must go downward. But the question is, we have a couple of numbers here. We have a +2 and a +1. Let's first of all consider the wrong option. What would happen if we go down 2 and over 1 and construct a line? So I try to construct a line like this, and I can extend it upward. It's clear that this line is not at a 90-degree angle to the others. This angle is more than 90 degrees. This angle is less than 90 degrees. So this had a slope that was -2-to-1, clearly not the right answer. So the original line had a slope that was 2 to 1. Taking a slope that is just the negative of it doesn't get us to the perpendicular line. So let's look at another possibility. The original line, we just said, had a slope that was in a 2 to 1 ratio. Instead of just taking the negative of that and having a negative 2 to 1, let's see what happens when we flip it as well. In other words, take the reciprocal. So let's go down 1 and over 2. So let me plot a point there. And if I draw in a line that goes down 1 and over 2, that's looking pretty perpendicular. Well, let's go in the other direction just to make sure. So if we had gone up 1, we should go 2 units to the left. And let's continue that line right there. Right now we are looking at a line that is, in fact, nice and square here. It is nice and perpendicular to the original line. So let's review. What was the slope of that line? We went down 1 and over 2. So the slope of that line is negative 1/2. What is the relationship between 2 to 1 and negative 1 to 2? They are negative reciprocals of one another. So in other words, if we switch the rise and run, we flip the numerator and denominator and take the opposite of one of them, we will have the negative reciprocal, and we will have created a perpendicular line. That line could have intersected the original line anywhere. If I have a negative 2 to 1 slope, a negative 1 to 2 slope, I can create a perpendicular line here. So all that matters is what the slope is. So all of the perpendicular lines to our line, the original line, let me write the equation, y equals 2x minus 3. All perpendicular lines would be in the form y equals negative 1 to 2x, or negative 1/2 x plus, and I'm going to write b here because b could take on any value that we want. It doesn't matter what the y-intercept is. The first one that we drew in had a y-intercept that looks somewhere between 0 and negative 1. The second one has a y-intercept that is right at negative 3. We can change the y-intercept around as much as we want. We will still have a perpendicular line as long as its slope is negative 1/2. In the second case, we can verify that this actually works. We haven't proven it, but we're going to verify it by doing it a couple of times. We had negative 2/3 x plus 4. Let's start right here at this point of intersection, and let's use the negative reciprocal as a slope. So the perpendicular line would have to have a slope that is the opposite of negative 2/3, and its reciprocal, which would be 3/2. That means the delta y value will be 3 every time the delta x value is 2. So if I go over 2 in the x direction, I should go up 3 in the y direction and plot a point right here. Let's draw a line in and look at that. It is very perpendicular to the original line. And if we go in the opposite direction and go 2 to the left and 3 down, that's still a 2 to 3 ratio. It's a negative 2 to negative 3 ratio, which is the same. And I draw that line in. We have a nice perpendicular line. The key is that the original line had a slope of negative 2/3. Any line that has a slope of 3/2, whether it's where the pink line is or anywhere else, as long as the slope is 3/2, it will in fact be perpendicular to the line y equals negative 2/3 x plus 4.